Good morning, and today we're going to continue talking about parallel lines, and today we're going to kind of do the opposite of what we did yesterday. We're going to take those angle relationships and we're going to prove that the lines are parallel. Okay, so yesterday we said if two lines are parallel, then for example 1 and 5 are corresponding angles, so we would know over here 1 and 5 are corresponding angles, so we would know that these two lines, if these two lines are parallel, then 1 and 5 have to be congruent. Well, today we are doing the converse. If you remember from last chapter, the converse means that the front and the back kind of switch places. So instead of if these two lines are parallel, then angle 1 and angle 5 are congruent, we're going to say if angle 1 and angle 5 are congruent, then we can determine that these two lines are parallel. Okay, that's the converse of our corresponding angles. Now the converse of alternate interiors, same idea except with alternate interior angles, 4 and 6. Converse of alternate exterior angles would be 1 and 7 or 2 and 8, right? And so on. Then converse of consecutive interior, same idea, except now, remember consecutive interior we know are supplementary, so 3 and 6, if they're supplementary, we can determine these angles or these lines are parallel. And likewise, consecutive exterior, we know 1 and 8 are supplementary, then the lines are parallel. So if we look here, it says which postulate or theorem can be used if we are told that angle 3 and angle 7 are congruent, which one can be used to show these lines are parallel? So 3 is here, 7's there. They would be corresponding down to the right from the point of intersection. So it's the converse of the corresponding angles, and it's technically a postulate. I'm not going to make you guys put postulate or theorem. You can just put converse of the corresponding angles. All right, letter B. Once again, 1 and 7, we find them. They're on the outside, exterior, alternate exterior. So it's going to be converse of the alternate exterior angles. And our final one, angle 3 and 5 are congruent. Those are alternate interior. So once again, converse of alternate interior. All right. Now down here it says, which sides of QRST are parallel? If you know that angle 1 and angle 2 are congruent. So angle 1 right here we know is congruent. I'm going to put an arc. Angle 2, here, let me fix that arc for 1. So if angle 1 and angle 2 are congruent, then we can take a look here, QRST. If those two are congruent, we know that this line and this line, QT and RS, have to be parallel. We don't know about QR and TS. They may be parallel, but they might not be. Okay? But QT and RS have to be parallel. That would be the converse of alternate interior angles. Okay? Now we have a few proofs to look at. We always know with our proofs, we always start the same way. So angle 1 is congruent to angle 2, and that was given to us. Okay. Now angle 1, we look is right here. Angle 2 is right here. Our end goal is to prove that L is parallel to M. So if we look here, L is right there. M is right here. To show that those are parallel, do you see how this white line, that is our transversal here? So 1 and 2, if they are congruent, they are alternate interior. So then L is going to be parallel to M, and that's by the converse of the alternate interior. Okay, and that's all there is to that proof. So if I were you, maybe pause it, take a look at this next one, give it a try. Once again, we are told the given. That is where we always start. So angle 3 and angle 6 are, I know it's kind of hard to fit it, so supplementary. Remember, that means they add up to 180. And our reason This is the given. Okay, now for number 2, reason 2. If 3 and 6 are supplementary, they add up to 180, then we know that L is parallel to M, okay, because those are consecutive interior angles. So it'll be the converse of consecutive interior angles. All right, the final thing we're going to talk about today, if we look down here, we have the transitive property of parallel lines. Okay, this tells us if line A is parallel to line B and line B is parallel to line C, then we know that A is parallel to C. And we can cut out that middleman. So we look here. Once again, we are given some information. We're going to start with that. So angle 1 and angle 2 are supplementary. I'm just going to put SUP, S-U-P-P, as the abbreviation. And also we got to fit in here, angle 3 is congruent to angle 4. And that's given. Now, if something is given, usually we're going to use it. Not always. They might give us a trick. But let's look at the fact if 1 and 2 are supplementary. We don't care about any of this right now, just 1 and 2. Between X and Y, those would be same side exterior or consecutive exterior angles. So we can determine if they are supplementary. That means that X is parallel to Y. And as we said on all of these, it's our converse of, in this case, consecutive exterior angles. Now, we look at the next thing, 3 and 4 congruent. Those are alternate interior angles, so we can determine then that Y is parallel to Z because it is the converse of alternate interior. All right, and so we are almost done then. If X is congruent or is parallel to Y and Y is parallel to Z, then we know that X is parallel to Z because we can cut out that middleman and determine then that those are also parallel by our transitive property of parallel lines. You guys can just put transitive. I will accept that. So, hope you guys have a great day. There is a Delta Math assignment. Keep in mind, I made some custom problems on this one. So you don't have unlimited guesses. You don't have unlimited problems. Take your time. I believe you have 2 chances for each of them. So give that a go and good luck. Hope you guys have a great day.